Hi everyone, are you able to hear me clearly and see my screen clearly? All right, great, great. All right, so great. Everybody is able to hear me and see my screen clearly. And before I move, there's a question from Sapna. Also, here is today's chat. I mean, this notes. All right. So a question from Sapna is, I have a query. I don't know what's wrong with this statement that I'm running. Can you please guide me? All right. Here is the statement. Hadoop jar and then okay, and then input. Okay, this is correct. And the output, and the mapper is this, and the reducer is this. Okay. So this file that you are handing over, it has to be in the local folder. Okay, that's okay. That's okay. Even if it's deprecated, it's okay. All right. There is another one called files file. All right. Now, question is that I don't think this file is located in the local directory. Looks like this is in HDFS. When you say ls, normal ls without Hadoop, do you see anagram underscore mapper? So this location is wrong. This file has to be in the local directory, not in a HDFS directory. While input and output are with respect to HDFS. Okay. So the script has to be in the local directory, while input and output in the HDFS. Do I make sense to you? All right, we can take it offline and we can discuss it. All right, Sapna. All right. Karthik's question is how to copy CSV file with fields have values having in it. Okay. And how to move to Hive. All right. So yesterday we talked about two ways to load data into Hive table. One was directly copying the data into HDFS and then creating your table on top of it by specifying the location. The second way was to create the table without the location and then using the load data syntax. Did that work? Okay, so you can do either. The only question here is that it has first, it has the header, right? it has field values in it, right? All right. So what you can do is, yeah, what you can do is either remove the header, okay, and create a separate file. Okay. Or try using a Unix command to remove just the first header using head or tail command. All right. Okay. Okay, good. Yeah, using tail command, you can just tail the entire file except for the first line. Okay. There's a command called tail, and using that, let's say your file has 15 lines. So what you do is tail minus 14 and the file name, then it'll print the last 14 line and save it in the next file. Yeah, thank you, Jitendra. That's another option. So basically the idea is to remove header and then move on. Yes, Sapna. So Sapna, what I was saying is, in this command, what you see on my screen, these scripts have to be in your local directory. Are they in your local directory or in the HDFS directory? HDFS directory. Keep them in the local directory. Local means in the console. When you say ls, you should see these files. All right. Okay. And second is that while you're specifying, you don't have to specify the HDFS file location. Instead, you have to specify the local file location. So the thumb rule is the code should be in the local directory, data should be in HDFS. All right. Though later on, if you are, let's say, in the production environment, keeping everything in HDFS makes sense because using a workflow tool, with HDFS is far more easier. Okay, we'll talk about that option. All right. For now, just keep this in the local directory, and also you don't have to specify the absolute locations. The relative locations will be good. All right. Was I able to answer your question? Okay. And Karthik, was I able to answer your question? Okay. So maybe I'm understanding your question wrong. So let's say you have a file, it has a header, right? You have a file, it has a header, the name of the columns, and then there is a file. When you are loading data into Hive, the first file, sorry, the first line contains the column names, right? So you don't want the column names to be going to the Hive table while loading the data. And therefore, it will better that you remove the header from the file. Okay, do I make sense to you now? So use the load command to load the data. And second, use the load command to load the data. And next is before loading the data, remove the header from it. Okay. 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 A better idea, Karthik, would be if you send me an email, support at no big data with your problem statement, I should be able to solve it. All right. Support at no big data. Yeah. I get every email. All right. All right. Great. Okay. Any other questions before we move forward? No questions. All right. All right. So today we are going to discuss a very important point, a very important topic called NoSQL. All right. So hello everyone. Okay, great. So should I start with our discussion on NoSQL? Great, great. All right. So the biggest advantage of NoSQL is that even if you have no expertise in SQL, you can confidently say that you are an expert at NoSQL. All right. All right. So before we jump into NoSQL, we will clear few definitions, and then we will try to understand what is the need of NoSQL data stores. Okay. So let's first understand what does it mean by scale out versus scale up, or horizontal scaling vertical against vertical scaling. So scaling out or horizontal scaling means increasing the resources, while vertical scaling or scaling up means increasing the size of resources. All right. So imagine that there was this cart owner. There was a cart, and he only had one horse in the cart, and and he had to carry more weight in the cart than a horse could handle. So he has two options. One, either sell the horse, buy an elephant, or he builds a cart in which he can add more horses and then add those horses into the cart. Okay. So while the first one, where he is planning to buy buy an elephant, that's called vertical scaling or scaling up. The second option, where he's changing the architecture of the cart in order to fit more horses, all right, that's called horizontal scaling. Now, which one is better in your opinion? Yes, which one do you think is better, and why so? Correct, correct. So yes, Thank you, Ali. And those are very good answers. I think everybody is reading those answers. All right. Yes. Basically, today our load can't be handled by a horse. So we are, let's say, going ahead with elephant. Tomorrow, if this load cannot be handled by an elephant, then do we wait for a dragon to or a dinosaur, or do we wait for elephant to become stronger? No, right? Therefore, horizontal scaling or scaling out, meaning building a cart which can handle many horses, is a better idea, right? And moreover, you will be surprised that an elephant is hardly equal to two, two or two and a half horses. Okay, unlike the assumption we have, and that's in effect true. So it's a very important, it's a very important point. And so far before Hadoop, what is it that people have been doing? They were doing vertical scaling or horizontal scaling. Correct, Kush. Yes. So I have seen many organizations doing the vertical scaling and then realizing that they need a better plan. All right. And I have seen many organizations doing chest thumping that they have this kind of superpower computer or they have upgraded and so on. I'm going to take you through a usual case study. And this case study is, it's not hypothetical. It's not something which I made. This is the story of every failed startup in 2000s. All right. From 1998 to 2005, this was a common story because of which a lot of startups suffered. Okay. And the story is about building a massively popular service. So on the day of launch, the life is beautiful, and all you do is everything that was running on your desktop, on your workstation, you move it to a shared, remotely hosted MySQL with a well-defined schema. Okay, so here we are talking from the perspective of the database, and because database is the one which is maximum loaded. So from the day zero, I mean, the initial public launch, we're pretty happy. We open the champagne bottles and do the initial public launch. All right. The life is great on the day zero. Suddenly, you do some PR, you publish in newspaper, and service becomes very popular. And suddenly, you realize that there are too many reads hitting the database. And this is something you have planned for. So what you do is, in these circumstances, a typical developer or typical engineer, what they do is they add a database called memcached or some other similar caching solution. What it does is, instead of querying the database, the web application, the user starts querying the memcached, the commonly available data, the data which does not need much of a logic that gets served from the cache. Okay. Now, when you put caching in place, okay, caching is by default. Caching by default means the data is at two places. One that is inside the cache, other inside the actual database. Is everybody clear about the caching part? And when you think about it, it will take some time to update the cache. Let's say there's some data that, let's say, you always think, when I take you through this story, you think about Amazon's detail page or Amazon website. You think about Amazon's detail page where you do the buy now. So instead of preparing it again, let's say we are serving it, we prepare all these pages upfront and let it be served by memcache, as in from the cache rather than being queried from the database. That's called caching layer, right? So now at this point, the reads will not be strictly ACID. Who can tell me ACID? What does it mean by ACID? ACID are the properties, are the four properties of the database. A for atomicity, C for consistency, yes, I for isolation, wonderful, and D for durable, meaning a change is atomic, change is consistent, change is isolated, and change is durable. All right, that's what it means by ACID properties. Isolated means if two people are trying to make changes to two different things, it should not mess up each other. That's isolation. Okay, so the cache data must expire, and there is always a time delay between modified and the one that's being served. And therefore, the moment we say we have caching layer, it means that we have made our system inconsistent, slightly inconsistent. Okay, keep this in mind. Third is, fine, now, after applying memcached, suddenly the overall load on your database has decreased by 1/10, decreased to 1/10. Okay, means the earlier if the load was 10, it's 1 now. But the service continues to grow in popularity. If this happens, if your service still keeps on growing and there are too many writes hitting the database, okay, at this point, maybe since you have become popular, you might raise some funding, and with the banker's money, you buy this really high-end database server, okay, having 16 cores and have 128 GB RAM and banks of 15,000 RPM hard drives. All right, or maybe you buy really costly SSD. Now this sounds like a great story. If you still become popular, and when you get some money and your service is popular, you will start hiring all kinds of product managers and so on, and you will start building all kinds of features into your website. And every time you're creating a feature, the way you do is that you add more tables, and hence when you serve the page, there will be more joins. And as joins keep on growing, the overall time taken to serve will be high. And when this kind of situation arises, you start denormalizing. What does it mean by denormalizing? It means that either you start duplicating data into multiple tables so that you don't have to do the joins, okay? Or you break down multiple tables into one table. So at this point, you have done two things so far. One, putting a caching layer. Second, denormalizing, apart from buying a very costly hardware. Now, the moment you hear the word denormalize, you will be shocked that why are we denormalizing. It takes a lot of it takes a lot of time to understand why we normalize in first place. Okay, I mean, I'm telling you my story. At DE Shaw, it took me some time to understand what does it mean by normalizing the tables. Okay, first year I learned, okay, this is how you do the normalization. This is how you build the great database architecture. And the next year, I'm denormalizing. All right, I'm unlearning what I learned just because of load, and I got the shock of my life that why did we normalize in first place? Okay, so when the load increases, you do all crazy things. Okay, so still, if your website is really popular and useful to people, it will grow in popularity and it will keep swamping the server. At this point, instead of you being happy, you feel stressed out because things will be too slow. And the next thing you start doing is, let's stop all kinds of server-side computation. Okay, because we have a nature to do a lot of server-side computation, like doing currency computation, doing time computation. Let's delegate it to either the web layer, the application layer, or leave it for the JavaScript or for the presentation layer. Okay, and even at this point, there'll be some queries that are too slow. So what you start doing is you start doing periodically pre-materialization of most queries. Let's say you observe that these are the 10 queries that keep coming all the time and there is no change. So what you do is you pre-prepare the data for those queries. You pre-prepare all the answers for those queries and try to stop joining in most cases. All right? At this point of time, the reads are okay, but writes will keep on getting slower and slower. And this was the next thing I had to do at DESHA while I was building this kind of database, that we dropped all the secondary indexes. Because let's say there is a table which has 3 indexes, primary, and there are 2 secondary indexes. Indexes means the database has a functionality called indexes. That means that when you query on the columns that contain indexes, the query becomes really fast. Okay, it's like when you prepare index of a table, all it does is it takes all the values from that particular column on which the index has been created, and it prepares a sorted ordered list of values from that column, and then marks the location of every value to the row number. That's called an index for our understanding. Now, at this point, you start removing indexes. Now, if you see the load or the velocity, the second V of our big data definition, the velocity or the load made us do crazy things with the database. When you buy the database, these are the few things which database vendors try to sell to you. Okay, they try to sell to you the consistency, that they try to sell to you the Court's theorem, the normalization, the foreign key infrastructure, the indexes, and so on. So at this point, when you realize that you are not using the basic functionalities provided by a database, the functionalities such as primary key foreign key relationships, joins, secondary indexes, and proper normalized structure. So and you are not getting consistency anyway. So at this point of time, you start questioning, why are we using the normal database in first place. And because of the database, Amazon suffered a great loss on Black Friday. After that, they bought all kinds of hardware because they thought that buying the hardware will solve their problem. But at the same time, somebody did a great innovation at Amazon. And what they did was they built a NoSQL database, because of which all the hardware they had bought was not needed. All the hardware that they bought was not needed, and then they ended up building AWS, the Amazon Web Services. Okay, because they had too much hardware lying around, and then they thought, okay, maybe we can build this kind of service to the other people as well. And now that AWS has become the more profitable than usual Amazon. All right, coming back to the point. So this is where the story of NoSQL started. And it's a story of everyone, because after the point number seven, the almost everybody gave up that we can't do anything much. We cannot go beyond this. Okay, and that's where NoSQL database plays a role. All right, is everybody clear about the story? Is anybody else facing the disturbance? All right, let me just check if, yeah, I'm connected to the correct. All right. Okay, so that's the story of RDBMS. Great. Now, we have already answered these questions. Let me rephrase. So the reason we needed NoSQL was this. Okay, first was where to store our humongous data. Second, high availability, meaning many users should be able to update and read concurrently. That's high availability. Third is scale out architecture, meaning we should be able to add as many cattle or as many animals as possible into the cart. Meaning, in our case, we should be able to use many machines simultaneously to cater to all the users. Okay, you can think of Facebook, for example. The people across the globe are simultaneously updating and reading the data from a central database. How they have achieved it? They have achieved it using a scale out architecture parallelly. All right, so this is why we need NoSQL. So in traditional sense, no, the use of a NoSQL database is that, I mean, when you have so many queries to answer to, and when you have many updates coming in from many different users, and there is a huge database that you need to build. In those cases, you need NoSQL. All right. So the core idea behind any NoSQL is distributed architecture. Keep this in mind, distributed architecture. Every time somebody says that our database is distributed, you should always think in terms of the table, the table getting sliced into parts and being served by many machines. Now, when you slice the table as in some rows, first few rows are in one machine, next rows are in some other machine, and remaining rows are in some other machine. That's distributed architecture. But when you have this kind of architecture, you have to mark some kind of identifier on the rows. And that's where the ID for every record comes into play. And they cannot be relational, because if they start being relational, they will lose their performance. They are open source. They can manage huge data because they are distributed, and they are schema free, as in they don't have the rigid schema. Okay, because if you have imposition of a schema on the database, it becomes impossible to scale. All right, so in single word, if I have to summarize all these points, it's the scalability. All NoSQL databases are scalable. All right, there are more than 150 NoSQL databases in the market. The other point that could be important here is the open source. Why are these most of NoSQLs open source? Can anybody answer that? Yes. More contribution. Yes. So if a database is not open source, no organization would like to put the data, and as Ted said, free from vendor lock-in, right? That's exactly the reason. When I was building Tbits Global, my last startup, so we kind of built a database. It's kind of a document store. And it was very difficult challenge for us to sell it because it was very proprietary. So we had to do all kinds of we had to get into all kinds of agreements saying that in case our company goes down, we will open source it and so on. Because of which the adoption took a hit. It was difficult to adopt. So open source, if a database is open source, only then people would adopt. Otherwise, it'll become a vendor lock-in and nobody will take it. Therefore, if you are planning to build a database organization, make sure it is open source. All right. So this is the main reason. No vendor lock-in. Yes. All right. So like I'm just saying whatever Ted has said earlier. Yes. No, Karthik, it doesn't have, none of these NoSQLs have those relational concepts. Primary foreign key is not there. A question from Mohit: how do we compare blocks concepts with having different rows on different machines? You mean HDFS blocks? Yes, just stay with me and then you will get it. All right. So when we understand the architecture of HSpace, this question will be answered. All right. So Ali's point is, so NoSQL is practically like CSV, kind of, yes. You will understand it as we go ahead. So NoSQL is not a file, it's a database. It's a data store which is continuously running in network, listening to your queries, answering your queries, and making the changes if needed. All right. While on the other hand, CSV is just file format. Good. So, all right. Interesting. So I'll try to stop this. All right. So there are different kind of NoSQL stores. There are different kinds of NoSQL stores. I'm calling NoSQL stores, not NoSQL database, because database word has different kind of expectations, right? The first kind of NoSQL store is the column-oriented or white column one. They look very much like a table, and basically they look very close to our traditional data stores. Okay, so they provide us kind of tables in which we can store data and we can update data. Okay, second one is document. Second one is the document kind of databases where we have, so document kind of databases, and in document kind of databases we have the complex objects as individual row. Okay, so every table is collection of documents and every document is a complex object. All right, so we will talk about HBase, which is column oriented today, and document oriented. The best example is MongoDB. In MongoDB you have something called collections. Instead of calling tables, we call them collections, and in the collections every record is a complex object like a JSON object. Okay, and it would look like that there are, every record would contain TV shows. TV shows contain seasons. Seasons contain episodes. An episode contains reviews. An episode have cast members as well. So basically, when you have to store complex data, instead of just array of values in each record, then you go for document-oriented database. Then the key value, these are the most primitive kind of database. So these are the most primitive kind of data stores, NoSQL data stores. This is where the story started. The whole story about the NoSQL data stores started with Dynamo. With Dynamo, the 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 this was the first data stores created by Amazon when they had a really bad day on a Black Friday. Okay, so after that they worked hard and created this Dynamo data store. It was nothing but a distributed hash table, meaning a hash table saved on many machines parallelly. That was Dynamo. And on the same line, Memcache DB, Redis, and all these other data stores are also similar to that. The fourth one is graph database. Neo4j is a good example. So when you have to store the complex relationships, such as a person is a friend of somebody, that person likes something, and he's also friend of somebody, and so on. Okay, so this is graph database. Okay, so this kind of structure like Facebook relationships and so on are generally stored in graph specifically for the computation. If you want to do certain computation on this data, then you would first like to build a graph and then run the algorithm on the graph. Okay, so these are the four large buckets of four different kind of data stores. And a question from Nada is, it mostly used to handle unstructured data. It generally handles semi-structured or structured data. All right. Unstructured data, you just dump it in HDFS unless we figure out the fields in the data, we don't put it in the NoSQL. All right. So Tad's question is the graph type mostly used in healthcare, like DNA structures? It does. It is, yes, it is used in healthcare, but it is also used in social graphs. Okay, in the social graphs, where you have imagine there's Twitter, and on Twitter there are 15 people following each other, and so on, and you have to compute the value, the net value. In those cases, the graph data stores come into play. All right, so this is a typical comparison between SQL databases and NoSQL. While SQL databases have been there for quite some time, they are 30-year older than NoSQLs. And the example of the SQL databases is MySQL, Postgres, Oracle, and NoSQL ones are MongoDB, Cassandra, HBase. And the model at SQL, all of these SQL database follow relational databases, relational model. There is a paper by Cod, and most of the relational databases are modeled around Cod's theorem. Okay, but in this case, in case of NoSQL, it varies. There are different kind of databases and data stores. All right, and with respect to schema, all of the SQL databases have the structure, and the data types are fixed in advance. But in case of NoSQL, the table don't have to be defined upfront. Okay, table schema doesn't have to be defined upfront. The scaling is vertical, as in you have to upgrade the hardware. In case of NoSQL, almost all the NoSQL databases are horizontally scalable. Development model in case of SQL is mixed. Like for example, MySQL was open source, and the Oracle and Microsoft SQL was proprietary. In case of NoSQL, most of the NoSQLs are open source. Support for the transaction. All the SQL databases follow the ACID properties: atomicity, consistency, isolation, durability. Just look into ACID properties if you're confused about it. It's important to learn. And in case of NoSQL databases, the label varies from database to database. All right. So to manipulate data, this is something very important. To manipulate data, in case of SQL, in case of SQL databases, all of the database provide you a structured query language to make the modification. But in case of NoSQL, every database has different API. The consistency with respect to the consistency can be configured, and most of the SQL databases have strong consistency. In NoSQL, it depends on the product. All right. Now, let's talk about consistency. Let's talk about a very important aspect. So, when we talked about Zookeeper, we told very clearly that if you are looking for a database which is strong at consistency, don't use Zookeeper. Okay? Because the Zookeeper was strongly consistent, meaning you remember that when we talked about Zookeeper, that a user makes the changes, it goes to all the machine, it tries to save everywhere. And in case somebody else is accessing data, they might get the older data and so on, right? So most of the NoSQLs failed to give consistency, and there was a very good reason. The reason was to provide the availability. Okay, so most of the NoSQLs have to sacrifice one out of the three: consistency, availability, and partition tolerance. All right. So the CAP theorem was a big, when none of the data stores could provide these all three properties, then CAP theorem came into play. The It was by a scientist named Eric Brewster, and it was also called Brewster's theorem. Okay, so it said that out of three properties of a data store, one, consistency, meaning all the nodes see the same data at the same time. The second, availability. There is a guarantee that request will receive a response, whether successful or failure, but request will receive a response. That is the guarantee. Okay, that's availability. Partition tolerance means some of the machines go down in the network, still the system remains functional. Now, so these are the three properties against which most of the systems were judged. Okay, so and they found that no system can provide all the three. No system can provide all the three. And probably this diagram will make it very clear. Okay, what do you see the first one? What do you see the first one? This one is relational database. Okay, a relational database has generally a single machine, and all the users, whether they are trying to make modifications or trying to read data, they are talking to the same machine. They all are talking to the same machine. And the reads and writes both are happening on the same machines, which means if that machine goes down, there is a power failure, there is no backup. There's no backup, and therefore therefore this kind of system is useless, because if a system cannot provide a failover or cannot provide tolerance to the shutdown of few machines or network failure, these systems are known as uh, partition intolerant. They can't tolerate the partition. Okay, partition means the network partitioning. Second is the available. It's not highly available. It's not highly available because only one machine is catering to both readers and writers. Therefore, it's the availability of such system is very low. The second kind of model is more popular. You can see the second model, this one. In this model, there are two machines, A and B. The writers go to A, while readers can go to B or A both. And when a writer writes something at A, that change propagates to B over the network. That means it's going to take some time for the data to reach B, and until then, B will be serving the older data. So the second kind of model is not consistent because the replication of the data from A to B is going to take time. It's going to take some time, and therefore the users who are reading from B will be reading the older state, correct? But this kind of model is very, very much available because users can read from A as well as B, and no single machine is a bottleneck. Next is partition tolerance. If there is a network failure between A and B, users will still be able to read from this database, right? Therefore, this kind of database, which is running on two machines, A and B, is partition tolerant. So MongoDB MongoDB and Zookeeper fall into this kind of model. The third one, the one you see in the third one, is the case of, did we study any such system so far? Yes. Have we studied such a system so far? In this, you have A and B. B is kind of cold backup, which is ready to serve, but all the service is being done by A. Yes. So what have we studied so far such system? Where you have two machines, A and B. B is useless completely, but is keeping the mirror image of A. And all the users are coming and talking to A for getting the data or the metadata. Yes, that's right. Kush, Barsa, and Ramana. Yes. So this was the model in case of name node and the secondary name, in case of the name node, and what was the standby name node. So this is standby and this is the name node. So all the users are still interacting with A for the metadata and B is the backup. So HDFS is consistent because only one machine is keeping the data at this one time, but it is not available. But it is partition tolerant because in case one machine goes down, the other machine will take its place, right? Did I make sense to you? Did you get all the three examples and the CAP theorem? So what we see here is you have three different models. None of these three models have been able to cater to the end user. So if you have anything else in mind, you can tell, can there be a structure which is different from these three and can cater to all the three requirements like consistency, availability, and partition tolerance? Oracle provides RAC. I think Oracle, the database that Oracle provides falls into this category. This one. Okay. So if I was designing, if let's say I was designing the HDFS in name node, I could have installed the MySQL for the metadata and so on. All right. So yes. All right. So Manjunath's question is peer-to-peer in Cassandra. but Cassandra achieves consistency with performance per query. Okay, so Cassandra is also not can be configured for either availability or the consistency. It is up to us. All right. So in other words, in CAP theorem, that we always need partition tolerance when we deal with big data or huge number of queries. We need many machines, right? And if we have many machines, we would need partition tolerance. So partition tolerance is something that we cannot compromise on. The only difference lies in between the two. The only trade-off is between the consistency and availability. Some data stores provide consistency, some provides the availability. And instead of providing consistency, most of these databases provide eventual consistency. Okay, eventual consistency. What you see here in this diagram, what you see in this diagram is, while the data is being written, for some time there will be inconsistency, but eventually the data will reach B from A, and and B is going to have the same data as A, and hence eventually everything is going to be all right. There won't be conflicts, there won't be parallel writing at A and B, which means data get corrupted and inconsistent. So these databases, instead of providing consistency, they generally provide eventual consistency. All right. All right. So Priya's question is, so is the best one in the eventual consistency, and what defines the delay? The delay is defined by two factors. One, how many machines are there to which A has to replicate? Okay. In case of Zookeeper, the the leader had to inform about a change to the majority. Correct? So that is one delay. How many machines are there on which replication has to happen? Second, how fast is the network? That defines the delay. Okay. Did I answer your question, Priya? All right. Great. Now, so we talked about few things: why NoSQL, kinds of NoSQLs, and why most of the NoSQLs can either provide consistency or availability. Okay, I hope these three diagrams had made you crystal clear about the CAP theorem. Good, good. If you have a question, please feel free to ask. I would love to answer it, because CAP theorem is generally a model which people are very afraid to explain. Dad's question is, in second model, doesn't the Zookeeper redirects the read client to the node having most recent copy? Not really. Not really. It redirects to the node, any node, which is basically in the network. All right, because the client cannot keep track of every change and their versions. All right. Manjula's question is same as Tad's question. Is it happen in third model as well? Okay, so in the third model, all the reads and writes are from A, not from B. Therefore, it is consistent because everybody is reading from A, not B. B is just keeping the copy continuously. And since user is not reading from B, people don't realize that B is having older data. Okay. Only in the case of failure, some changes which might not have got replicated to B, those changes will be lost. But that's very rare. Okay? And most of these databases, if you remember the model of highly available HDFS, they have made sure that it's not only A, but also client keeps on sending changes to B, both A and B. Okay. A question from Kush. In case of RDBMS, if we have multiple DB instances, in case of RDBMS, if we have multiple database instances, still it will miss consistency or availability, right? Mm, in case of RDBMS, we cannot have a model in which same data is being catered from multiple machines. Okay, the way when there was no SQL, there was no NoSQL in the RDBMS time, and we had to build humongous highly available systems. So what we did was we manually sharded the database, meaning a table was broken into parts. And when the user request is coming, we would redirect the user's request to that particular instance. Okay, so generally the way we divided the data was based on the geographic location or based on arbitrary criteria such as name or something else. So based on those models, we used to use the RDBMS for high availability where all the databases stayed independent of each other, and it was the application, it was the software application which was switching between different databases. Okay, did I answer your question, Kush? Okay, good. So Jitan's question is, AWS provide function facility to read replicas for RDBMS. AWS provides function facility to read replicas for RDBMS. All right, this I'm not sure of. And okay, I'll have to take a look at, are you talking about Redshift or some other database? Okay, I'm not sure about, okay, I'll have to take a look at that. All right. So this was our CAP theorem where we have discussed about why a system can be either consistent or available. All right. System can either be consistent or available because in the higher load, we always want a system to be distributed, and we always want a system to be running on many machines. Therefore, it has to be partition tolerant. All right. So while we discuss more things as we go forward, we also need to discuss one idea called how do you store data? Visually, when we take a look at the table, we see columns and the rows. Columns are on x-axis, and on the y-axis you have rows, right? Amp ID is one column, name is another, first row, second row, third row, right? This is first row, second row, third row. These are the three rows. Now, question that everybody asks is, how do you save this data into a file? And what do we mean by file? When you think about file, you always think of file like a big row of characters or big row of bytes. So file is a serialized storage. It's not a rectangular. storage the way we look at in this editor. The way we look at in this editor, it looks like it's a rectangular storage. No, it's a sequential storage. Okay, coming back to it. So a table can be stored, can be converted into sequence of character, either row wise or column wise. Say for example, in typical sense, when we are storing CSV file, this is what we are trying to do. Emp ID name, then 10 Joe, after that 12 Mary, 11 Kathy. This is how we are storing in the row oriented manner. And CSV files or any other Excel file and all of these usual kind of storage, we basically store the data in the row oriented fashion. Is everybody okay with this? Sometimes some of the researchers found that if we store it this way, column wise, and then compress the data, it is going to be more, it is going to save more space. Okay, therefore they came up with the idea called column oriented way of storing data, meaning first 10, 12, 11, then Joe, Mary, Kathy. This is how the data would look in the disk. Okay, so this is the difference between row oriented and column oriented. Now question you may ask is, why do you think that column oriented databases can be compressed better? Why? Why? What makes these databases, this format, to be more compressed? Okay, so before I answer that question, let me take a step back. That how do you compress something? How does the compression happen? The way compression happen is something that is being repeated too frequently, we give it a symbol, and instead of repeating that symbol, we mark it that this symbol is being repeated 13 times or 5 times. You must have seen this in the songs, that a single line is being repeated multiple times, so we put -2 next to the lyrics, right? Somebody's unmuted. Okay, all right, so you must have seen yeah. So the way we compress a song or the lyrics is by putting dash next to the name, right? Next to the line, -2, -3. If the same line is coming n number of times or same word is coming n number of times, we basically put the number. In the same way, in the compression, we, if there is a symbol that's getting repeated a lot, or there's a sequence of symbols that's getting repeated, we give it a single symbol and then store that. So that's, and you can see that if we are grouping these columns together, since most of this data is going to be quite repeated in the same column. Imagine that you have age, so there'll be a lot of people in the similar age, and therefore it'll be easier to compress that. Okay, so similar data, if kept together, can be compressed easily as compared to different data. Therefore, the column oriented data store are, when the compressed, are better. Okay, did I make sense to you? What does it mean? So I try to answer two things here. What does it mean by row oriented data stores, and what does it mean by column oriented data stores? So visually there is no difference. It is, the difference is only in the way they are storing the data. It is only in that way. So row-oriented data stores store the data row-wise, while column-oriented data stores store the data column-wise, as in 10, 12, 11, Joe, Mary, Kathy. And since similar data is coming together, it's easier to compress this and the compression results are far better in the column oriented. That's the only reason why we are talking about column oriented database. Yes, any question at this point? All right. All right. So there were some data stores which were very clever. They came up with this idea called column family oriented data store. It's like being really political, that we are both column oriented as well as row oriented. It's up to you how you want to use us. So Jamil's question, let me answer that. Can NoSQL be used like normal data RDBMS? Yes. Okay, they can be. It's just that some of the operation like joining two tables is difficult, and there are some more differences that we will talk about. All right. All right. So there were some data stores which were very clever, such as HBase. They said that we are both column family oriented, which means we are both column oriented as well as column family. So columns were grouped into column family. CF1 contains emp ID and name. Here you can see that. While CF2 contains only one column. Now, the column family oriented database means the data in the column family 1 will be stored in this way, in the row oriented way, as in 10 Joe, 12 Mary, 11 Kathy, and then 23, 33, 45. So each column family is stored in row oriented fashion. Right? So, okay. So other question from Saptrishi is NoSQL is actually not only SQL, and heard it somewhere. Yeah. So yeah, that's the full form, but actually NoSQL was created like a Twitter handle because one of the teams who were implementing a database, they put it on the Twitter before they were going to the conference, and that's how the NoSQL became popular. All right. So all right. So you can see that I'm going ahead with the column family oriented database. So you can see that you have CF1, CF2, CF3 in first table, and each column family contains only one column. So, and in the second table, there is a single column family containing all. So which one is column oriented and which one is row oriented in these? Yes. So first, in the column family oriented databases, each column family gets stored. So it'll be stored like 10, 12, 11, followed by Joe, Mary, Kathy, and then 23, 33, 45, right? And in the second one, the data will be stored in this fashion: 10, Joe, 23, 12, Mary, 33, 11, Kathy, 45. So first one is, yes, first one is column oriented, while second one is row oriented. That's right. So this is, yeah, this is slightly looks like a schema. Okay. And that's the only schema you need to define in case of HBase. All right. So Jamil, is it clear now? You wanted example for this? So example in the sense what? So we'll talk about this again. Okay. For now, I'm just talking about, the values in this. We will talk about HBase. How does it store the data actually? Okay. So here we are saying that in case of column family oriented database, column family CF1 will be stored first, and then CF2, then CF3. If okay, if I have to do it like manually, so I'll take these three values, put it in here, okay, maybe like this, and then put semicolon. Generally, these special characters, what I'm putting as comma, they are generally non-printable characters, okay, non-printable characters. So you can see this is how it's going to store. Okay, it's going to store in the file in this manner. All right. A question from Tad, but can document file having column family oriented schema for similar information? Yes, they can. It is up to them. All right, let me reread the question. Can other document have different column family oriented scheme for similar? They can, just that the performance will be different. Okay, all of these things are being done for the performance. All right. Did I answer your question, Jamil? All right, good. So there was one more question which I missed. Manjunath's question is, in case of CF2, how compression will happen? You mean to say this one? Yes. So column in case of column family, there's only one column, and even if you whether you store it row wise or column wise, it's always column. So 23, 33, 45. Okay, this is how it's going to go into the disk. Okay, so from the client perspective, the table remains a table. It's only the internal of the database. Okay, was I able to clear the question, Manjunath? So it'll be stored, the CF2 is going to be stored 23, 33, 45. If there were more columns in the column family, look like this. Okay, so I think this diagram would make it very clear. If there is only one column per column family, it will behave like a typical column oriented storage. If there are all the columns lying in a single column family, it will behave like a typical row oriented storage. All right. So these were the few things I wanted to discuss with respect to the with respect to the with respect to the NoSQL. So we talked about why do we need NoSQL. Then we also talked about the features, and then we also talked about comparison with SQL, and we talked about the CAP theorem, and then we talked about column oriented and row oriented kind of model. All right, we also talked about a case study. All right, any questions at this point? All right, let's move on. So this was an overview of NoSQL in general. Now let's talk about, yes, we are going to do that today on HBase. Manjunath's question is there any restriction on number of column families? Not really, not really. Okay, so yeah, Ted will be doing the kind of hands-on with how do you add row, how do you add data onto HBase, but querying, we are not doing it here in this session. Okay, because HBase does not provide a query language, and people generally use MapReduce or some third-party drivers to talk to HBase. Okay, Mohit's question is, can there be many label nested columns? Can there be many label nested columns? No. It's only column families contain columns, and column can't contain further any column, or column families cannot contain any other column family. All right. It's a good question. Next is question is from Saptrishi. Is it the responsibility of the developer to define a column family in general? Yes. And that's the most important part. We need to understand what goes in column family, what goes in column name, and what goes in the row name. Okay, we are going to do that discussion now in a concrete fashion. All right, that lies in the understanding of data model. All right. All right, so probably the worst way of defining database, HBase. HBase is CP, consistent and partition tolerant. It is not highly available. Okay, we will understand why, and is it okay to be CP or not. All right, it is based on Google's Big Table. It's a column family oriented database, the way we have defined, which means the data is stored underneath such that data inside column family comes together. It is based on Google's Big Table. This is the third component. Google published three components paper. First one was HDFS. First one became HDFS. Second became the MapReduce, and third became the HBase. Okay, it's good for storing hundreds of millions or billions of rows. If you have less than that, use your usual MySQL kind of database. Okay, because HBase is not great for smaller data. It's strongly consistent, not eventually. All right, it has automatic sharding, meaning the table gets broken automatically into many region servers. Okay, it has automatic region server failovers, as in case one machine goes down, other takes over. All right, next is it has a strong Hadoop HDFS integration, which also means that it doesn't work elsewhere other than Hadoop. To process data, you will have to use MapReduce, and it provides API. And again, just like Hive server, HBase server is written in Thrift. All right. By default, there is an API in Java, And since it is in Thrift, therefore you can access from any language. It provides the idea of coprocessors, which is similar to the stored procedures. And for searching the data, it provides Bloom filters. I mean, they are more like indexes, okay, just high performant indexes. All right, so this is the classic diagram of HBase. It lives on Zookeeper and HDFS. Okay, keep this in mind. So HBase is made up of one master, other reason server. There are many reason server and there is one master. APIs talk to the master and then APIs get redirected to reason servers. Okay, just like name node and data nodes. And these reason servers store the actual data. Okay, these reason servers store the actual data, and master keeps the track of which reason server contains what range of data. Okay, and region servers indirectly store data in HDFS, and for the coordination between master discovering its region servers or the API discovering master, everything happens through Zookeeper. All right. Is the diagram clear to everyone? So there is a master, then there are region servers. Region servers store the actual data, and master only keeps the record of which range of data is in which region server. All right. In other words, this is how it look like. So on one hand, there is HDFS, other hand, there is Zookeeper cluster. Master depends on Zookeeper cluster as well as master talks to HDFS for storing the information, as well as master queries Zookeeper to find out its region servers. As soon as a region server comes up, it informs Zookeeper that, hey, I'm up. And by creating something called, how will you region server inform the master by the way of Zookeeper? By creating what kind of node? Anybody? We talked about persistent and the other kind of node in the Zookeeper, ephemeral node, right? Ephemeral node. So region servers, when they come up to give their attendance, they will create ephemeral node, and when they will go down, ephemeral node will disappear from there, and when master queries, it will not find that particular region server because that ephemeral node has disappeared. Okay, so master discovers about its region servers up or down by the way of Zookeeper, and everybody except for Zookeeper, everybody stores their data in HDFS. All right, is the architecture clear to everyone? So actual data, Ted's question is, if actual data gets stored in region servers, what is the store in HDFS? I'm going back. So each region server has section of the table. Imagine there's a huge table, and some of the part of the table is one region server, some in another, some in another, and this table is converted into a file called H file and then put it in the HDFS. Yes. So Manjunath's question is, since in HDFS we cannot write the file once, it is written to HDFS, how HBase handles CRUD operation? Good question. We will talk about it again. All right. So was I able to answer your question, Ted? All right. So you can see this. So this is another way of looking at the architecture, that there are region servers. Region servers are basically keeping the the actual section of the table. Okay, a table is stored partly here, partly here, partly here, and master is just keeping track of from which range to which range is on which machine. That's all. Master is just keeping a track of the range of the rows, and that's where there is a need of identifying the rows. Okay. Yes, that's right, Saptarishi. By the way, virtue of data nodes and HDFS, every H file gets replicated in the HDFS. Okay. All right. So tables are automatically partitioned into regions. Each region comprises a subset of a, a table of rows. All right. And every region is denoted by the table it belongs to, its first row and last row. Okay. So basically, a table is broken into regions, and these regions are denoted by table it belongs to, the first row, which is inclusive, last row, and initially the table contains only single region. As the size of the region keeps on growing beyond a threshold, it is splits into two halves and goes into two regions. Okay, until the first split, all the loading will keep on happening against a single machine, right? So as the table grows, the number of regions also grow. All right. So let's take a break here and come back after the break, and we will go understand more detail about the reasons. All right, so is everyone back? Can we start? All right, so should we? All right, so now we are starting with this discussion where we left. All right, so okay, so let me try to. All right, so this is how it would look like. This is what is stored in the master, and every region server contains many regions. Okay, like this. All right, let me try to demonstrate to you if I can. All right, all right. So let's think about a table. All right, let's think about a table like this. Initially there are, say, one record into this, and then after some time there were some more records written to this, and then some more records. Okay, and then some more. Now at this point here, when it's basically reaches certain threshold, it reaches certain threshold here. Okay, after this will be broken down into two. Okay, there'll be, the table will become two equal halves. All right, and how do I break it? So right now, let's say there are 4 records, and after splitting, there will be two regions on, let's say, on 2 different machines, and they will have one. This looks okay. So you will have 1 and 2 records, and from here the further writing will be started. Okay, so like this. Okay, so one big table, when it went beyond a certain size, was broken into 2 halves, and this might go into one region server, and this might go into another region server. All right, is it clear? All right, so a very important part to understand is every record has a key. Key is a string, or key can be any binary data. It has a key, and this data that you see here is ordered by the key. Okay, so if it has A, it'll have, say, B, and this contains C and D. All right, so basically the data in these tables, in the region, each region is ordered by the key. The who generates the key? That's a good question from. So it is the developer, while adding the data, they will put the key. Okay, and accordingly, let's say you are trying to add something like art, a key with art, so it will be inserted in between the two. Okay, and let's say somebody is trying to add data with respect to, say, chart. Chart will go somewhere here in between C and D. Okay, so basically the idea is that the data is capped into parts, into different sections. Okay, small sections, and the data is ordered by the primary key. There is only primary key actually. So every record must have a unique key. Okay, and that's not only for HBase, but also it is true for every kind of NoSQL. That every NoSQL have a unique identifier for a record. Okay, so you can always see that, you can always imagine this way, that region is a range. Every region is a range. Like for example, this region is from A to C, and this region is from T to Z, and this region is from I to M, and the second one is not included in this. Okay, generally instead of Z there will be something called end of line, which will be marked not Z, because that means there is no region for Z. Okay, and so on. All right, so let's say you're trying to add, continuously adding data to this particular region. This will keep on becoming bigger and bigger, and then it will do the fission, as in break down into two parts. All right, two equal parts. And let's say you're trying to add data into this, it'll keep on becoming bigger and bigger, and after a certain threshold it will split into two. All right, so Priya's question is, how do we make sure that every record has a UID? Okay, so yes, so when you're storing the data, the way you have to plan that out. So every language has a way of generating unique identifier. There are libraries, you can use those. Manjunath's question is, what is the default split size? Is it configurable? Yes, it is configurable at the HMaster level. Okay, and the default size, I'm not sure, it's around 32 MB. Not 32 MB, actually bigger than that. I think it's equal to the size of the block by default. I'll show you. Okay, if you go into Ambari, you can find that. All right. Question from Saptrishi is, does data move from one region to another? Not really. Okay, not really. Basically, regions keep on automatically becoming bigger. The regions can be moved from one region server to another. Let's say this machine goes down, automatically this data will be loaded on any of the other machines. All right, these are regions, and this is region server. Region servers contain many regions, and so on. All right, let me try to show you. Okay, average load is this. Okay, so this is the default replication factor for the file. Okay, let me check. Yeah, maximum region file size. Yeah, so this is one, we have kept it at 10 GB. We can decrease it to a smaller level for if we want it. Okay, by default, this is what is configured. All right. A question from Karthik. What happens if the table is deleted? The reason server becomes free immediately for another table. So yes, if the table is deleted, the reason servers will become free. Okay. And since the table is generally distributed on multiple region servers, not only one region servers, therefore, all the region servers become little free. All right, good question. So, is it clear to everyone? So initially, when we are talking to AdSpace Master, we are adding more and more rows to our data, it's going to add the data into only one region server. And as the data grows, the region will split and become two. All right. Now, so this was the architecture. It's important to know the architecture, but most important thing to know about AdSpace is the data model. All right. And why do you need the data model? We need the data model so that we can architect our column family, table names, and so on accordingly. All right. A question from Priya. Uh, the replication factor defines on how many region server the table will reside on. Is it so? As per my understanding of the region servers, a region is available on one machine. Okay. Though the file which is underneath, is generally capped on two machines, is having the default replication. Okay, since every region is stored as a file, and hence that file dictates how many replication, how many copies does it have to have. All right, good. Now moving ahead. Now the data model part. So let me. All right, let's just go through this quickly, do a hands-on, and then describe the model again. Okay, so the first important part in the data model is table. Table contains row, and row is identified by the unique row key. Okay, row keys do not have the data type, and this is a very important part. So you can actually put a movie into the row key, and this was my interesting revelation when I was architecting one of the database at Cassandra, and we were wondering where should we put the data, and then we realized that we can actually put the data in the row key. Okay, and that was a very good model. Row key and column key, we kept the data in both. Okay, so you can put anything inside row key. So you have a table name has to be string, while row key can be a binary data. And all right, and there is something called column family. This you need to define upfront. You don't have to define how many columns will go into a column family. You just define that, okay, these are the 3 column families. Okay, nothing much. Just define these column families and that's it. You can keep on adding as many columns as you want in the column family. Okay, you can keep on adding. A column is something column also has a name, just like row key, column also has column name. And column name can also contain any kind of data. And you can keep on adding any number of columns to a column family. So while creating a column, you always say that, okay, this column will be added into a particular column family. All right. So we got two places to put our data so far, row key, column name. Third is the cell. Cell is something which contains the actual data. Cell can have multiple versions, and cell can also contain binary data. Anything, not necessarily there is no data type per se. Okay, so there is no data type for the actual. So every cell has got versions. By default, there are three versions, three last values of each cell kept. These versions by default are based on time, but you can manipulate them. You can keep different criteria for the versions of each cell values. Okay, so the data model that you see can be visualized like this. Okay, this is a table. It has a row key and it has a column family. And so you can see in this table, you have column family personal, column family office, and personal contains a column name and residence phone number. Office contains the phone number and the address. This is a row and this is the row key. All right. Did it make sense to you? All right. What does it mean by column qualifier need not to be consistent between the rows? Okay. Data within the column family is addressed by the column name. Column name need not to be specified in advance. Column name need not to be consistent. Okay. Let me go back a couple of steps. So now let me talk about this particular line. Okay, this line is from the paper by Google, paper on big table, and this is probably the best way to define the data model of HBase. Okay, this is I mean this definition, you can't really take out a single word and you can't add any more word. You don't need to add any more word. So this is most succinct definition of the data model. Let's start from right side. The way you look at HBase table, you always look at it like a map. Map is what? It has key and it has value. Okay? You remember the dictionary? Dictionary has a name and then it has the meaning of the name. And this dictionary is ordered by the name, right? In the same way, a table is an ordered map. Okay? Where the data is ordered by the key. All right? Not all the maps are ordered by the key, but dictionary is. So it's more like a dictionary. It has the keys and there are names. All right? And it is multidimensional. Unlike dictionary, in the dictionary you only have value as the meaning of the word. Here, the value is multidimensional. Value contains array of values. Okay? Okay? It is persistent, meaning it is saved. Okay, if you have made certain modification to HBase, it is kept in the disk. It is not lost. It is distributed. So this kind of a dictionary or sorted map is distributed, meaning so you can all, if you're visualizing the dictionary in your mind, you can think of some pages of the dictionary on one machine, some pages on another, some pages on another. And just like on every page, you have at the top the range. Okay, the range. From A to B, it's here. B to C, it's here. Okay. In the same way, same like dictionary, the pages are regions where the data is distributed. Also, it's sparse, meaning the rows, the cells, some column names could be completely empty, containing only one value. Some might be full. Okay. So this is how you visualize the big data, the big table or HBase table. Did it make sense to you? All right. All right. Let's try to create our table, and then it'll make more sense. Then we'll take a very good example, and this will make a lot of sense. Yesterday only, one of my students, who was trying to construct a database. He called up and he basically had skipped this part, so that's why he could not model his data. So I had to explain to him that this is how you can design it. All right. So it's important to pay attention here. So let's try to do some exercise. Okay. So Cloud X Lab. A question from Manjunath. Since key is unique, how HBase identifies in which region file to store the data? Does it use hashing? Not really. The HBase master just keeps the range with them. Okay, it just keeps the range with it. It doesn't keep the hash code. It just keep the range. Okay, just like a dictionary, you have at the dictionary, if you pay attention, at the top right you will see the range. Okay, you'll see the range saying from here to here is on this particular page. In the same way, that particular notation is capped with the HBase master. All right. So yeah, range as in it doesn't keep the track of all the values. It just keep the first and the last. And since the data is ordered by the key, it's easier to locate that particular row or record. All right. Coming back to it. So here we go. So let me just try to show you from the UI, and then we can use from the console as well. Okay. So you see here, there are a lot of tables. So here, let's say I'm creating a table called okay, I'll just put my name, Sandeep, and phone book. Okay. And there are two parts to it. I'm calling one as personal, other I'm calling the official. Okay, there are two properties to it, and I'm saving it. Okay, let me just search for it. All right, so there is no data to display yet. All right, there is no data to display, and what's wrong with it? So there are two column families, personal and official. Okay, so what is this? No, this is something else. And under this, is the UI something wrong with the UI or? All right, let me go back. All right. Yeah. At the bottom, there is a row. Let me take this out. Yeah. So you can see that there is either you can bulk upload or you can add a new row. While adding a new row, we can simply say, okay, we can simply say, what was the, all right, let's say I'm taking this particular example and I could say row key, let's say I'm keeping everybody's phone number as the row key or say email ID as the row key. Or what else should I keep as the row key? Let's just keep the phone number or let's say first name followed by last name. Sandeep Giri is the row key and I'm saying the column family. I'll say official or personal and I'm adding the phone number here. Okay. And personal, I'm saying landline or let's say personal email ID. Okay. So what you see here is, okay, we can just submit it. Right. So you can see that I have added the data. Now, the important part is that if I'm adding now, let's say I'm adding somebody else's name, let's say Sundar. Okay, Sundar P. This time I can say personal and I could say something like personal, some other mobile number, okay, and put some other value and skip the other parts. All right. While the first record contains two columns, email ID and phone, second one contains only one called mobile number, and there is nothing inside another column family. Okay. So are you also creating your table, please? So if you go to HBase, okay, create new table, give the table a name, create column families, and submit. And then locate your table. For me, it is this one. And then good. Question from Sundar is, won't numeric row key improve the performance? Not really, not really. Because range can be in the byte, right? It doesn't matter whether the range is with respect to the bytes of a number or bytes of a string. Okay. So are you able to create your table? All right. So what we learned is that while creating a table in HBase, we must define the column families. And why do we define column families? Why do we define column families? So that the data which is similar to each other, the data which we want to access together, we may want to keep it together so that it's faster. Yes. Yes, while creating the table, the column families are needed. Okay. Yes. All right. Ali, Barsa, Jamil, Jin, Karthik, Kush, Manjunath, Mohit, Nitin, Omkar, Prashant, Priya, Ramana, Sapna, Saptrishi, Sheikh, Mishra, Stephanie, Sundar, Tad, Thomas. Are you able to see? Okay. All right. So I'm adding a row key. Okay. In my case, I have just say Ramana. Okay. That's the row key. And we have to put the column in one of the column families. Okay. And let's say office department, I'm keeping it here and I'm putting some number. Okay. No, it's not. The drop down is coming for me because I have entered in past. It's an autocomplete, not the drop down. Okay. You have to make sure that you type it that way. Okay. This drop down is coming because whatever I'm typing, it's based on that. So you have to say of whatever column family name. I have given two column family name, personal and official. And okay, that's why you have these two. So this is how you define the column name. So column is identified by column family name, colon, the column name. Okay. Did that make sense to you, Ramana? So put some key, whatever column family you have defined, pick any one and then save. All right. Why are you facing this API error timeout? Strange. I'm just trying to test. So, Ramana, are you getting the error timeout while creating a table? Or while creating a row? Okay, so what is my row key? My row key is X. Not row key, my column family is X. All right, so maybe I'm just plain lucky that this has opened for me. Okay, try refreshing, Ramana. So you create a new table. You create a new table and then add column families and so on. So Ted is saying that now after I refreshed, I don't see any rows. Maybe the earlier one did not get committed. Yeah, there are no rows actually. All right. But you have to, did you create rows, Ramana? I see. I see. Maybe they did not get saved or something happened at the UI. Ah, I see. You have to, it is must to provide the column family name. If you are adding something, make sure that in the field, while you're saying some, you should put your column family name and colon the column name. Column name can be arbitrary. Column name can be anything. Row key could be anything. And same as you can have any value. All right. Is everybody with me? All right. So let me try to draw again. I know it is, my handwriting is pretty bad. Okay, but all right. So you can always imagine that HBase table like this. Okay, it has got some, let's say, so this is one column family. Let's say you have, and this is column family 2. Okay, so when we are adding rows and just this is the row key. This is the row key. This is, so this is column family 1 and this is column family 2 and this is the row key. Row key. Okay. Yes, if you try to write the same column, same row key, it's going to overwrite the data. If you put the same row key again, it's going to overwrite the if you write the same column name as well as row key, it'll get overwritten. Okay, so what I'm trying to demonstrate here is that when you are, let's say, creating something, so you can add more and more columns to it. So like this, okay, you can add data anywhere at any point. Okay, so if you're thinking that this is one column, this is another column, and so on. Similarly, this is one column, this is another column. So you can keep on adding more and more columns the way you have been adding more and more rows. Okay. So at any point of time, just like in a spreadsheet, you can go to any cell and edit it. Similarly, if you specify row key and column name, you can modify anywhere, anything. Also, this contains some data. This also can have good amount of data, similar to the row key. Okay, similar to the row key. All right, there's a question from Saptrishi. In my table, I tried to add a second record with the additional columns from the first. The columns are displayed in the order that was entered, even though there are common columns between the first and second record. What is your table name, Saptrishi? Okay, so let me take a look at that here. Okay. Yes. So basically, this diagram shows that there are two row keys. Okay, 1 and 2. These are the two row keys. First row key contains address fields, the city, street in first column family, and first name and last name in the second column family. And here it's different, and so on. Okay, so your question is why this and this is not being displayed one above another, right? That's your question. So yeah, so the way, yeah, that's why it's basically it's basically a multidimensional hash table. Okay, it's multidimensional hash table, and also the, displaying something one above another is just a way of displaying it. Okay, that's a quality of, say, this viewer called hue. Okay, so it has essentially, it is difficult to display one top of another because the chances of column names not being shared are very high. They could be arbitrary column names. That's why. Okay, that's why in this definition it says that it's nothing but a multi-dimensional hash table. Okay, it's multi-dimensional sorted map. In this definition, if you see, is multi-dimensional sorted map. That's why that diagram suits better, because it can be sparse and therefore it may not be able to represent it properly. Okay, was I able to answer your question, Saptarshi? Okay, Ali's question is, if I add a new row with available column family name, yes. So if you keep the column family name as well as the row key same, it will overwrite existing. Let me try doing it. Okay, let me test it with my table. Okay, so you can see there is let's say Ramana was one, Sandeep Giri was another, and let me say that I'm trying to update the email ID of this person. I'm saying new row. I'm saying Sandeep Giri, add field, and here I'm saying personal and email ID. Okay, and here I'm saying this time some proper value. Okay, this is my email ID. So now you should see here that it has updated. Okay, it has actually added one more. Did I change the row key? The earlier there was a mistake in the name. Okay, let me try again. Sandeep Giri, and I'm saying personal, and I'm saying email ID. That's Sandeep at No Big Data. You see, this time it got updated. Earlier there was a difference in the key. All right. Tad, are you able to add the row now? Okay, let me take a look at your table. All right, Ali was able to answer your question. Thomas, question from Thomas is, I can add any column family multiple times with the same row key? Yes. When you say any column family multiple times, it means that you're trying to add many columns to the same row in the same column family. Yes, that's right, Saptarishi. column values within a column family are actually being stored closer to each other. Okay. All right. Going back to, let me try to. So Ted, you are trying to modify table called Ted. Okay, let me take a look. All right. So it has official and personal. I'm adding some data. Let's say this, adding a field, personal, and that's it. So it has added. So did I make something which you did not do, or it's not just working for you? I've made sure that I type the column name in the form of column family colon any arbitrary column name. Okay. Can you try once more? All right. Great. So this is the way we can add it a table in case of HBase. You can do the same thing from the console as well by using HBase space cell. All right. Yes, it's more similar to Excel than a DB. That's correct. So I was trying to visualize something. I Then I realized that okay, I can do it better using Excel than drawing a table. All right. So all right. So I'm hoping that everybody is able to create their table and add some rows to it. Who wasn't? All right. So great, wonderful. So probably everybody is able to. Now let's take a very good example. This is the example for which big table at Google was made. Okay. As I've told you that HBase is modeled after Google's big table. And this example is the reason why Google's big table existed in first place. Okay. So a quick overview. How does Google work? Google basically crawls everybody's website. Crawls means downloads everybody's website, goes through the website, extract the content from every website, keeps a relation between, keeps a record of which website is pointing to which other websites. Okay, based on who is pointing to which website, okay, it's giving the votes and it's ranking the pages. Okay, I think I can draw the diagram better. So let's say you have a website A. You have a website, let's say A, which is being pointed by B, and you have C website, c.com, a.com, b.com. And on website B, when you go, there is a link which is pointing to A. On on c.com, if you go, there is a link that's pointing to A. Okay. Now, who is more valuable, A or B or C? Correct, A. So A's page rank is higher. Now, A is having a link to, say, E, while C is pointing to a link D. Which is more valuable, E or D? Correct. So that's exactly how PageRank algorithm works. So B is voting to A, C is voting to A. So B.com, C.com, A.com, E.com, and D.com, they all have their website. On their website, they have put a hyperlink to the other website. So B has a hyperlink to A, C has a hyperlink to, and so on. So the idea behind the way the initial versions of Google was made was that out of these, E has got highest value, A has got second highest value, D has got third highest value, and B has got fourth, and C has got fifth. Why? Because C gave some of the value to D and A, B gave some of the value to only A. All right. So there is a formula to this, how much value each other gives, that we can we'll discuss it when we discuss the GraphX algorithm. Okay, when we discuss GraphX in MLlib, then we'll talk about these ideas. Okay, so this is called PageRank. This is called PageRank. All right. So it's great that everybody understands it so clearly. That okay. So now this diagram looks cool, but if you think about it, every time we are going to evaluate the value of E, we are going to find out all the pages that are pointing to E. Similarly, every time we are going to evaluate the value of C, we are going to also find out who all C is voting to, right? So when Google is crawling the world, it has to maintain this relationship. Who is giving who the vote? Who is giving the vote to who? Okay, and that's what. And to keep this, they first try to use HDFS, but that wasn't solving any problem because this is a structured data. This is multidimensional data. We need to quickly able to find that who all are pointing to A, or who all A is pointing to. Correct? Therefore, they came up with this kind of model. They said, instead of keeping it in HDFS, let's keep it in the database, and let's build a database around this. Okay, so, and that's where this kind of data model comes into play. All right, so the way they designed it is, they kept row key as the URL. URL is the website URL. Okay. Reversed, we will talk about why reversed later. Okay. And they created two column families. One is called contents, other is called anchor. In anchor, we keep on adding more and more columns as we encounter more and more websites. Okay. So the first column family is, the column is blank. Okay, column name can be blank. Column name can be blank. Just give me a second, I need to check a few things. Just give me a second. All right. So are you able to hear me? All right. So what they did was, in as we were discussing earlier, there's something called column family, the columns and row key and so on. So they designed it this way that row key contains the URL, and there are two column families. One is called contents and other is called anchor. First column family contains an empty column because column name could be empty, and that basically contains HTML. Okay, so whenever they downloaded first website, first column contains the HTML of that website, and then the links. This website is pointing to this particular website by this name. Similarly, CNN.com was pointing to, sorry, was pointed by CNNSI.com as this, and by mylook.ca as this. Okay, so every time they crawled this data, they formed this HTML and updated the anchors, and this is the way they kept it. Anchors basically contain the information about who is pointing to this website. CNNSI.com has a href with the text as CNN, and mylook.ca has the href to this website with this name. So this website is pointed by this and has content like this. So every time they, let's say somebody crawled Microsoft, and they found that Microsoft also contains reference to this, so they updated here. So you can see clearly that if there are a billion websites in the world, there will be a billion rows to this table and billion columns in this table. Does it make sense to you? So at any point of time, if you have to find out who all are pointing to this, all you have to do is, for this row key, find out all the columns, right? That means based on how many people are pointing to this, its page rank will go up. All right. So when you're querying the big table, you can simply either query a particular row key, or you could say that give me all the rows for this particular column family or column. All right. Is this explanation clear? Now, the row key, okay, the row key can be of any size, Manjunath. The row key can be any size. The splitting happens internally when you keep on adding more and more data to a table. Okay, the overall data model does not get impacted. The splitting is something like internal. All right, so data model remains same. The way we look at the table remains same even if splitting happens. Okay, now if you notice that they have reversed the URL, why? So that the rows of a website remain together. Okay, what does it mean by that? As we have told you that the keys, okay, so while querying, we can query that give me the data starting from this particular row key, okay, and it will give you that particular cursor, okay, that it will give you that those records which are starting from that particular row key or in that range, right? So if we, let's say we kept the row key like this, okay, so mail.google and okay, and let's say, so if you see, if these are the row keys and this is sorted, so you can see that first record will be that of Google, second will be that of Microsoft, third will be Google, and then Microsoft. So they will not be able to kind of keep the data together because the data is sorted by the row key, okay? Therefore it is wise to keep the data in the reverse fashion, okay? It's wise to keep the data in the reverse fashion, okay? How many of you went through my discussion on the regular expression? Okay, so let me copy it. Okay, you must go through the discussion on the regular expression. All right, so you can see that using regular expression, I just reversed it. Instead of writing mail.google.com, I'm writing com.google.mail. Okay, so this way, if you see, if I sort this data, Google has come together and Microsoft has come together. Okay, so it'll be easy to go through all the URLs of the same organization if the data is stored in this way. That's why the row key is a reversed URL. Make sense to you? All right, so now a brief about what we have learned so far. The indexing is based on row key. Tables are sorted based on row key, and each region of a table has sorted row key space. Okay, everything in HBase table is stored as byte array, meaning binary data. You can store anything. Atomicity is guaranteed only at the row level. There is no multi-row transactions allowed. Column families have to be defined upfront while creating a table. Column qualifiers are dynamic and can be defined at any time. They are stored as byte array, so you can put data inside column names. Okay, all data model operations return data in the ordered sorted order. Okay, row key, column family, column qualifier, timestamp, etc. All right, so you can try the command prompt as well if you are interested. Okay, a question from Tad: does table splitting only applies to rows added and not on columns added like in PageRank? Does table splitting only applies to rows added? Yes, yes. So that's right. So the reason splitting happens based on the total size of the data. It doesn't happen only because of row adding. It can happen because of column adding as well. But it is splits vertically, not horizontal. It splits in a way that the rows are split, not the columns. Okay. All right, so here we go. So you can use the console as well to talk to HBase. So here we are saying HBase shell. This is the first. Let me also open a console. Make it a little smaller. All right. Let me copy the login. All right. So you can see that here. Okay, very good question, Saptrishi. So, a question from Saptrishi is that what happens when single row exceeds the split size? Okay, that I need to find out because I was exactly thinking about it. Okay, because the data, because it is splits based on the based on the rows, based on the overall region size. Okay. All right. So I have started the HBase shell. And here I'm trying to create a table. Okay, I'm trying to create a table. It says that the table already exists. Okay, so let me disable. Okay, and delete. All right, actually drop. Yes. So let me try to create this table again. So I'm saying, all right, if you want, you can also follow the same thing. All right. So I'm trying to create a table. You have to, you would like to define a different table. Okay. So if I say list, it'll show all kinds of tables. And then if I say list a strict table, it'll show only the tables starting matching this particular regular expression. And I'm saying put into this particular table, into this row, into this column, this particular value. Okay, that's what I'm trying to do. All right. So if I say scan, okay, so you can see that. Just a second. Oh, this is actually disabled. So it's not allowing me to. All right. All right. So yes. All right. So now I'm able to add it. I think it is enabled now. All right. You can change the table name and try it out. All right. I think somebody is disabling it and deleting it. Okay. I think I'll just use some other name. I'll just use some other name for this. And I'll say find this, replace it with 5 November. All right. So I'm trying to go ahead with good. So you can try this. I think it's not something difficult. You can all try. Again, we can put basically this syntax of putting shows that it can be, it is used like a hash map. Okay, it's a multi-dimensional hash map instead of a table. All right. Now, a question that all of you would ask is, where does it store data? Let's take a look at it. If you go into this particular folder, this will answer your question. Okay. This will answer your question. Let's go there and check. Okay. So let me go here. All right. Let me remove this from search. Okay. So here you can see that there should be the table. You remember the table name which I created? Sandeep phone book. Let me remove this text from the search box. Now you can see something here. Inside this particular folder, there is a folder for your table. Inside that, there is a region here. You can see region. Yes, this is the region that contains the that is automatically generated. This region is automatically generated, and right now how many regions are there? Only one region. Okay, so in this region there are two folders, one for official and other for personal. Now you can see that all the data related to this particular column family would be inside this, while all the data related to personal will be in this folder. Okay, now since it's kind of not what do you say saved, not saved as in it's flushed. Okay, let me flush it. Okay, flush Sandeep Giri underscore phone book. Is that the table name? All right. Sandeep Giri, Sandeep underscore phone book. Yes. Now you should see in this folder. Okay, you see that? So Sandeep Giri contains one region, and this is the column family. Inside the column family, this is that H file. Okay, it contains my data. All right. Also keep something important. Pay attention to it. You see, this contains blank spaces. Okay. Why it contains blank spaces? So that it can append data to this file without changing the file size. Okay. It's a common strategy. It's a common strategy of any database, so that when you are adding value to a particular row or when you are updating a particular row, it does not have to be reallocated. Therefore, every database leaves padding, leaves some space for the value in every row. Okay, it blocks the data so that it can directly write in that location of the file instead of rewriting the whole file. Okay, do I make sense to you? So this is the H file inside the column family. So you can see that. All right. Good. Are you able to hear me? So this is where the data is stored. All right. I think that's pretty much. If you want to query the data from a programming language, you can take a look at the API. Okay. The way you query the data, you provide something called a scan parameter, the row key to start, row key to end, and the columns to return. Okay. And optionally, you can run a filter on the server side before receiving the data. All right. So that's all about scanners. Okay, so you can run MapReduce on top of HBase, as well as there are ways to query the data, right? So we'll discuss the Bloom filters and from here onwards in the next session. All right. So thank you, everyone. Today we talked about NoSQL and HBase. In the next session, we will talk about continue HBase. We'll also do the hands-on exercises on Scoop and Flume, and then we will continue Scala and REST. Okay. So Manjunath's question is reason for disabling the table before delete and drop, so that reasons stop accepting the changes. Okay, that's the reason. All right. So see you next week. Next week we are going to start with Scala. Okay. First we will finish Flume and Scoop, and then we will start with Scala discussion. All right. Bye bye. Have a great week ahead. What is the link for regular expression? If you go into No Big Data My Courses, it should be there under My Courses. Okay. It should be there under My Courses. Let me check if it is there. Yeah, you must see this particular one, course pays regular expression. All right. All right. Thank you, everyone, and have a great day ahead. Bye-bye.